Hello and welcome to another video about Math 1000 material. This is measurement. And measurement is definitely something that you should be familiar with, some various conversions. The biggest thing that you're probably less familiar with is dimensional analysis. How you have the old unit and we convert it to the new unit. All right, doing this via fractions. We saw a little bit of this, but we're going to go much more into detail today. So, all right, we are going to be looking at one-dimensional, two-dimensional, and three-dimensional units. All right. So it's important to understand the differences between them and how we can operate them. So let's start with the stuff where probably most of us are familiar with. Distance conversions. All right. So I have some conversions here. All right. And again, all this I recommend goes directly to your cheat sheet. So if I have 78 inches and I'm trying to go to feet, we start by putting that over 1, right? 78 inches per 1 unit. That's what we have as a unit. When you set up the dimensional analysis, all right, the units are on the opposite side, and this one is a one step unit, right? There are 12 inches per 1 foot. Notice that the units will cancel. And then, all right, you multiply this across, and this would become, right, 78 times 1, all over 12. .5 feet, since feet is the only units that remain. Similarly, all right, 17,000 feet going to miles. The conversion from above, 5,280 feet per 1 mile. Units again cancel. And then multiply across and divide. 3 inches. Now notice this one, finally. I don't have something that is inches to feet. So this one I have to do multiple steps. So first, 12 inches to 1 foot. Units cancel. Now I'm in feet. There are 3 feet per 1 yard. Units cancel again. And now notice the only units that remain are yards, right? Multiply that across. And we see that we have 1/12 of a yard. The metric system, without a doubt, all right, is the fanciest system. Very, very nice. It's all measures of 10. Super, super nice. And, all right, the units are all consistent. Specifically, the prefixes of the units, right? Kilo, hecto, deca, deci, centa, milli. It doesn't matter if you're talking about length, mass, or volume. All right, those are the same prefixes for everything. You then just have to adjust. All right, if you are dealing with length, it's meters. Grams is mass, and volume is liters. So it's really just a matter, right? And volume is also cubic units as well. These are the single units. But the whole idea is that with these three, we can convert between them, and then you only have to change the prefix. Since everything is base 10, that is powers of 10, all right, it's all also just about moving the decimal. Okay? You move it directly according, all right, to where it is. If I'm trying to go from centa to deca, that means I start right here and I just count. One, one, two, three. And so I would move the decimal 3 spots to the left. And that's how it always works. This is a super, super nice little chart, and it's in the order in which you move the decimal. Let's look at some examples. So 3,500 millimeters to meters. Also, it's super important with miles. Miles is not M. The only thing that is represented as M is meters. All right. So it's super crucial to make sure that you use the correct prefixes. If you're going to use not prefixes, abbreviations. If you're going to use abbreviations, all right, make sure that you're using the correct one. Okay, 3,500 millimeters. All right, we're going to meters. So notice where we are. Mill is right here. That means 1, 1, 2, 3. 3 spots to the left. So you take our decimal, 1, 2, 3, and that becomes the new decimal. 4.315 hectometers. Hectograms, sorry. All right, going to centigrams. So now we're starting over here. Hecta. 1, 2, 3, 4 spots to the right. And that's how it always works. And remember, right, from your arithmetic days, all right, I counted 4 spots. When I have an extra spot, fill it in with a 0. All right, kiloliters. All right, to deciliters. All right, the only tricky part is really deca and deci. So just make sure that you're paying attention to that. So kilo, 1, 2, 3, 4. All right, 4 spots to the right to go from kilo to deci. Fill it in. $38,000 deciliters. Where dimensional analysis really shines, all right, is in the using of per, right? A distance per time period or something per something else. Meters per second, all right, represented as 25 meters per second. The division sign, all right, identifying the per, because you have units in the numerator and units in the denominator that you have to keep track of. Okay, so since I want to take meters per second to miles per hour, I basically start with just the meters. I look at my conversions and notice I don't see a conversion that easily goes to miles, but I do see one that goes from kilometers to miles. So that means let's turn that meters first. Let's turn the meters into kilometers and then, all right, turn that into miles. So that's 1, 2, 3 spots to the left. Now I have kilometers per second, and now I can set up my dimensional analysis. So we know that now we have 1.609 kilometers per 1 mile. And then, right, so now I'm in miles because my units cancel, but now I have miles per second. So then I want to turn that. So 60 seconds is 1 minute. And now I can see those units cancel, seconds and seconds. Now I have miles per minute. And then lastly, 60 minutes per 1 hour. And those units now cancel. And now notice, right? Miles divided by hours. Carry your calculations across. We end up with 55.9 miles per hour. So, all right, that's the real strength of dimensional analysis there. Um, Expanding that to area and volume. Now, be aware, you can get through almost everything with just these distance conversions because by definition, a square mile, right, or square foot, those conversions, it's just 12 by 12, right? Talk about inches. This square foot, right? 1 foot by 1 foot makes 1 square foot. Doing that in inches, well, that's 12 inches by 12 inches makes 144 square inches. You can do that with all the conversions except for, here's the big one, acres. Okay, we have a couple of acre conversions. Acre is already a squared conversion, all right, measure. So for most of them, you can do whatever values you have, just square them, all right, for all the distance conversions. But acres is already a square unit conversion, so make sure you have that one written down. Since we're talking about areas, a big thing to talk about is population density. And the general concept of population density is the population divided by the area. So, after Alaska, Wyoming is the least densely populated state. The population of Wyoming is 515,000 and change. Its area is about 100,000 square miles. What is the population density of Wyoming? Well, that means all you have to do is put the values of how many people are in Wyoming divided by the area. And it doesn't matter what units you use. In this case, clearly we are using square miles. Which gives us 5.3 people per mile squared. And that's one way to measure population density. You can do this by acres, you can do it by whatever measure, right? Do it by square inches. Metric conversions to area work very, very similarly. Okay. Notice the square mile. This is still 1 mile squared equals 1.609 kilometers squared, right? That 1.609 kilometers per 1 mile. So I still have the same conversions, but again, I have them all written out here in square conversions if that's helpful. Expanding this to volume. Volume is then cubic units. So everything in area is square units. Everything in volume is cubic units. All right. So 1 by 1 by 1. All right. That's why the units are cubed. Another measure of volume is what's referred to as capacity conversions. Capacity is about filling the empty space of something. All right. And capacity often is measured with liquid conversions. So quarts and pints and gallons. Okay. And notice we have liters. All right. So conversions between metric, all right, and standard units. So a pool has a volume of 10,000 cubic feet. How many quarts of water does the pool hold? So again, start with our dimensional analysis, 10,000 cubic feet. Looking at my conversions, well, let's see, I see a cubic foot to gallons conversion. All right, but we were actually looking for quarts. So once I get to gallons, then I see, oh, look, gallons to quarts. Also, big one, don't use G, all right, for gallons. Gallon is GAL, all right? G represents grams. Again, careful with the abbreviations. All right, and then 1 gallon per 4 quarts. Our units will cancel and multiply across, and we will get 299,200 quarts. The real strength of the metric system, all right, is the seamless conversion between volume, capacity, and mass. All right. Now, just be aware, this is just volume capacity. We'll see mass in a minute. Volume, 1 cubic centimeter equals 1 milliliter. The volume to capacity conversion is literally 1 to 1. Look at what we just did, 7.48 gallons per 1 cubic foot. Ugh, the calculation is terrible. But metric has such smooth, easy 1 to 1 calculations, and that's why we like it so much. All right. So similarly, all right, if you're doing anything with metric conversions, it flows. It's just so nice. It's just moving the decimal. All right. To that end, a fish pond has a volume of 220,000 cubic centimeters. How many liters of water does the pond hold? So notice we have our conversion, cubic centimeters to 1 liter. And that's just literally moving the decimal, which gives us 220 liters. This is what's so nice about metric conversions. I mean, 220,000 just becomes 220 liters. I mean, and 220,000 cubic centimeters becomes 220,000 milliliters. It is moving the decimal only. All right, looking at weight. So with weight, we have we have conversions, and now notice grams and weight. All right, kind of we go back and forth between mass and weight because weight actually incorporates gravity. All right, but we kind of use them. There's a conversion of grams to weight since we are on Earth. 160 pounds, 2 kilograms. All right, I notice that I see, all right, the conversion right here. Pounds to grams, all right, 2.2 pounds to 1 kilogram. So whichever conversion you want to use. £2.2 to 1 kilogram. Grams to ounces. I see that one right here. And again, every time, all I'm doing, make sure you line your units up on opposite sides. And your units should cancel out very, very cleanly. Here's what I was talking about. The metric system, all right, to between volume, capacity, and weight, that is mass specifically. All right. 1 cubic centimeter is 1 milliliter, which is 1 gram. This To go across three different types of units and to have a 1-to-1-to-1 ratio, that is truly, truly fantastic. To that end, and so this should go on your cheat sheet with asterisks and stars just because it's so nice, a 1-to-1-to-1 ratio. All right, so to that end, an aquarium holds 0.145 cubic meters of water. How much does the water weigh? So still doing dimensional analysis. We're going to be using this one right here, meters cubed. All right, and I can go all the way to weight. 1 cubic meter is 1,000 kilograms, which again is simply just moving the decimal. All right, or I mean multiplying 1,000 times 0.145, but it is just moving the decimal. And that's what's so nice about metric conversions. All right, one last little thing. So temperature, three types of temperatures. All right, Fahrenheit, Celsius, and Kelvin. Fahrenheit, this is the US scale, all right, based on the approximate temperature of the human body. All right. Celsius, based everything on water. 0 degrees is when water freezes, 100 degrees water boils. All right. Kelvin, this is the scientific scale about absolute zero. We have two conversions that we use these two formulas to go all the way from Kelvin to Fahrenheit or Fahrenheit to Kelvin. All right. So let's practice. If I want to convert 59 degrees from Fahrenheit to Kelvin, that means we want to start with our formula here. And then just a simple matter of solving, subtract 32. And then multiply by 5/9. That gives us 15 degrees. And then to take it to Kelvin, simply adding 273 and change. Just as a note, so Kelvin's all about absolute zero. Unlike Fahrenheit and Celsius, Kelvin isn't degrees Kelvin. You literally just say 288.15 Kelvin. All right. But again, two formulas. This one you should definitely be familiar with. Hopefully this one you are seeing more and more, ideally in science. Let's look at one more example. Convert 35 degrees Celsius to Fahrenheit. Oh, well, we have our equation. If I have the Celsius value, that means I'm simply just plugging that in. And then simplify that guy down. 95 degrees Fahrenheit. All right, another wonderful day. Hopefully that lecture was helpful. Have yourself a wonderful day.